for those who haven't met me before, I'm Hillary. I'm the station manager here at UW-NPS, and we are super, super grateful to have you back for another week of the Harlow Summer Seminar Series. I just want to give you a brief idea of the events that we have coming up in the next few weeks. We have no event next week because 4th of July happens to fall on a Thursday, so we hope that if you want to come up for our next event, will be on July 11th. And that is a really special one. We're having the return of the Wyoming Festival, which is a chamber music evening. And it's a set of composers that are composing and performing for the first, and musicians that are performing for the first time, brand new music that is inspired by the Greater Yellowstone ecosystem. So it's a really special event every year. I have people tell me that it's their favorite thing that they came to. And it's also a really funny opportunity to see the science folks among us being forced to have emotions, which is good for us. So I hope that you guys will come to that. I am really excited to introduce the two folks that we have for our seminar today. First, it's sort of amazing. I was talking to some of the folks that were here earlier, and this is actually a really lovely example of the collaboration between the University of Wyoming and the National Park Service here at AMK Ranch, because tonight we have speaking Laura Jones, who's the Branch Chief of Vegetation and Ecology and Management at Grand Teton National Park. And then we also have Anne Beeman, who is a graduate student at the University of Wyoming in the Department of Botany, and they are working together on sagebrush restoration. And then Anne is also one of our 2024 small grant recipients. And so that's a program that is put together and funded jointly by the National Park Service and the University of Wyoming to promote research that is of the highest priority to the park in terms of making more informed management and stewardship decisions. So this is a really lovely example and opportunity of that, opportunity to sort of appreciate that. Specifically, our topic today is going to be restoration of sagebrush ecosystems, which are both iconic in the Greater Yellowstone ecosystem and ecologically vital, but a large percentage of this ecosystem has been either damaged or is completely been lost. And so restoring and managing sagebrush and other native plants is a really critical but challenging task. And so, so Laura and Anne are going to talk about that. And then I did also want to say, we're really excited to have the whole team, or at least part of the team, up at the station this season. So we have Laura and Anne who are talking, and then we also have Dylan and Skylar who are also on the project, who are also staying up at the station this season. So it's been a treat for us to have all those folks around. I am going to stop talking now and turn it over to them, but I did want to just say for the folks on Zoom, if you can make sure that you stay muted during the talk, and then if you have any questions, just feel free to pop them in the chat, and then when at the end, when we have time for questions, I can ask them. So I will go ahead and turn it over. Whichever you want to go first.
Thank you, Hillary. Anne and I are really excited to be here today and to talk about the collaboration that we have between the University of Wyoming and the vegetation projects at Grand Teton. And just to kind of kick off a little bit on the roots of the collaboration, back in 2018, Dr. Daniel Laughlin in the Department of Botany was interested in this project, and he came out to visit and in fact met with Eric Kramer there in the audience and to visit the site. And Eric is then biotech, now oversees the native plant program for the park and has been part of this restoration. And it's great interest in working together. So in 2019, we had a graduate student researcher, Sienna Wessel, came and took our data of 11 years of monitoring and did an evaluation on that. And we adapted our practices from that. And the intent working with Daniel was always our next step would be, well, let's set up this next round. Let's set up the treatments in a way that we can test them scientifically. So worked with a study design and with Daniel and then they're able to now work with Anne to take a deep dive into that. So it's really nice because we've been very heavy on the implementation, and then looking to the university with an expertise in the research and the academic side of things really makes it much stronger. So super excited about that. And today's talk, we'll talk about the importance of sagebrush ecosystems and the threats and the land use history that brings us to our restoration and the restoration techniques that we used, and then we'll go into some monitoring data and then the work that Anne is working on right now. And for this first moment, I'm going to turn it over to Anne to jump into that background.
Perfect. Thank you, Laura. Okay, so I'm going to talk to you guys here at the beginning about sagebrush importance and the threats that these ecosystems face. So to start off, it's really easy, especially when you're driving down 80 in Wyoming, to look out across the sea of sagebrush and think, oh, that's just a bunch of a shrub. But in reality, the ecosystem is so much more complex and so much more diverse than that. Specifically, within Grand Teton National Park and across the West, sagebrush is home to a variety of wildlife that helps support these animals. And so here we have just a couple of the species that utilize and rely on sagebrush. The interesting thing about sagebrush is that it provides year-round forage, and that's the really, really important part about sagebrush ecosystems. You might have grasslands and especially monocultures of grass that also serve as forage, but they cannot be used as winter forage. And so this is kind of the really, really important wildlife piece of these systems. So specifically, kind of looking into some of these animals more closely, we have the famous pronghorn, and they utilize sagebrush throughout the season, again, year-round. We have bison. Again, you can frequently see bison throughout the park in the sagebrush steppe, and they feed mostly on grasses. And then this one is kind of surprising. Sagebrush steppe also helps out the grizzly bear. Specifically within the fall, it's great forage. Grizzly bears will utilize this area for berries and roots and tubers. It's also a migratory area to help these grizzly bears get to riparian zones. And then we also have moose. Moose utilize the sagebrush also throughout the entire year, specifically foraging on antelope bitterbrush. And then now kind of transitioning into birds, we have the greater sage grouse, which is a particularly important bird that people like to focus on. And this is because the greater sage grouse is an obligate, has an obligate relationship with sagebrush. That means that it requires sagebrush. So as sagebrush ecosystems dwindle, that is detrimental to this species. It's also important because since about 1965, the greater sage grouse has decreased in population about 80%, which is significant. So again, we have these guys in the park and they're often of great focus. So all of this is also important because wildlife viewing and photography is a very, very popular activity amongst the parks. And so this helps boost tourism. Actually, 1/3 of Grand Teton National Park is sagebrush steppe. It's easy to focus on the mountains and the forest, but this ecosystem is vital and important to all of the wildlife that exist in the system. Additionally, sagebrush steppe does not just include sagebrush. So these are some fun forbs, like wildflowers, grasses, and also shrubs that exist in these systems, as well as a couple of pollinators. So again, it's easy to drive down the road and just be like, what's all this shrub? But again, a healthy, intact sagebrush ecosystem is so much more than that. And then why does this matter? Why am I focusing my master's project on this? Why is the park putting so much time and resources into sagebrush restoration? The sagebrush historic range has actually declined by 50%. And so that's a significant decrease. Again, it's easy, especially because we exist in Wyoming. We see a lot of sagebrush to think that there's just a plethora of it, but it is significantly decreased. And so because of all of these reasons that I've described, wildlife, biodiversity, it's really important that we start focusing on maintaining, restoring, and monitoring these systems. So now I'm going to kind of transition into the threats that these ecosystems face. So we're going to start with wildfire. So wildfire is an important part of the sagebrush ecosystem. It's an important part of the story. It kind of helps revitalize these systems and jumpstart the successional process. However, recently, due to fuel buildup, fire suppression, and climate change, we've had a dramatic increase in wildfire within this biome. So you can see the black line, which indicates the sagebrush biome, and then the blue there indicates sagebrush-dominated areas. And as you can see, the fires are outlined in red and orange, with the more darker shades of red being more recent wildfires. And as you can see, we have a lot of really, really recent fires, and this can be detrimental because then this leads to the potential for invasion, specifically of annual grasses like cheatgrass. And so a lot of you have probably heard of cheatgrass. Cheatgrass is a really detrimental annual grass. It's really detrimental, especially after fire, because it really likes nitrogen-rich soils. And so a fire will come through and it will deposit all of this nitrogen from the ash, and then the cheatgrass is an annual. So it means that it colonizes really quickly. So it'll come in and it can create these large monocultures of just cheatgrass, which is essentially a complete conversion away from sagebrush steppe, essentially a loss of that ecosystem. Cheatgrass invaded areas that are monocultures have very low productivity. They don't support as much pollination or wildlife, and it's overall detrimental across the West. And so here specifically, we have the Greater Basin ecoregion. So we have Nevada here, and the red indicates areas of high cheatgrass risk. So as you can see by this map, there's a lot of high cheatgrass risk. This is kind of a cautionary tale. I understand this isn't the Greater Yellowstone ecosystem. I decided to show this photo today because this map is of an area that has a low resistance and resilience. This means that it is more likely to be invaded by cheatgrass. Typically areas with low R&R are lower in elevation, higher moisture, and overall higher temperatures. And so a lot of cheatgrass work and restoration in that regard has been focused on those low R&R areas. We are very thankful and lucky that in the Greater Yellowstone ecosystem, we exist in a high R&R area. This means we're at a higher elevation, we have more moisture, and we have cooler temperatures. So we have a little bit more resistance. A little bit heavier of a force has to occur in order for us to have complete conversion to these cheatgrass monocultures. However, with climate change, you never know what's going to happen. So this is definitely a possibility. We want to keep an eye out on cheatgrass. We do have cheatgrass within the park. So this is kind of important to keep in mind and realize that it's happening and it's a problem. So this graphic kind of shows the difference in different severities of resistance and resilience. So again, the low resistance and resilience there at the bottom is like Nevada, like the Great Basin ecoregion that I just showed you. Lower elevations, lower soil moistures, and higher temperatures, as opposed to high resistance and resilience areas and ecosystems like the Greater Yellowstone ecosystem, which exists at higher elevation gradient, higher soil moisture, and overall lower temperature. And then this is a USGS map that also kind of displays this in the context of the sagebrush biome. So again, we have that kind of white line that's going around the outside, and that indicates the sagebrush biome. And then as you can see in Nevada, where that graphic with cheatgrass was, it's bright red. And so that means that it's in a low resistance and resilience zone, as opposed to where we are in Wyoming, the Greater Yellowstone ecosystem is high resistance and resilience. And then this is some interesting data taken from the NOAA Moose Weather Station. It's easy to think that we're in such a pristine and beautiful area, maybe we're not impacted by climate change as much. And that is a fallacy, that is not true. We are definitely seeing the impacts of climate change. As you can see, since the 60s, temperatures in the area have increased by about 1.3 degrees Celsius. So that's a lot. And also notably, snowfall has declined. This is an issue because snow is important for sagebrush seed germination. So kind of both of these factors, we have to keep an eye out in terms of our sagebrush steppe ecosystems. And then this is just a little graphic I made kind of illustrating how all of these components are interconnected. So again, it's a very complicated system. Global change can increase temps, increase frequent droughts, decrease winter precipitation, and then those increased temperatures and droughts can then lead to an increased fire frequency and intensity, which can then help spark that positive or amplifying feedback loop with cheatgrass, which then can actually decrease carbon storage because grasslands actually hold less carbon, store less carbon than sagebrush ecosystems. We also have a decrease in diversity, both plant and animal or wildlife diversity. And all of this kind of works together. Worst case scenario, we get conversion or loss of sagebrush ecosystems or an overall decrease or degradation in the quality of the system.
Thank you. And before I go further into what the park has been up to, we know that my branch, the branch of vegetation, has been hard at work at this project, and the people involved, like Eric, like Molly Murphy on the invasive plants, Jasmine Cutter with the seed work. But it's also really something that's just behind the scenes that needs to be daylighted a bit. Is we've had this great multi-year partnership with the Grand Teton National Park Foundation, with grants from the National Fish and Wildlife Foundation, the Teton Conservation District, Wildlife for Tomorrow, and that's really been supportive of this project. And we have also a grant from Wyoming Game and Fish. And then this particular research is supported by University of Wyoming as well, and Wyoming Native Plant Society. And of course, we really appreciate the having this wonderful place to be for this talk and supporting researchers here at AMK. And putting this in a bit more context is that we're part of many national level initiatives. And I want to give a shout out to Tom Rodhouse, using this is his slide, as are several others peppered throughout. And Tom is coordinating this NP Sage effort, which is multi-park effort to look at sagebrush parks that are prioritized and work together on some of these projects and some of the research behind it. It also aligns with the DOI's, Department of Interior's Sagebrush Keystone Initiative and the National Seed Strategy. The Sagebrush Conservation Design is a USGS-led effort to look at the sagebrush biome holistically. And what you're seeing here in this map is the dark blue is these core areas, core sagebrush areas, which is healthy intact sage, a opportunity area, growth opportunity, and the other rangeland or highly impacted area. And so this kind of flips something that Anne had said about spent a lot of restoration efforts in these low resistance and resilience ecosystem types. And with this look at the whole sagebrush biome, it kind of shifted the priority in the framework to let's protect the core and grow from there. So just to give a little circle on our area, Jackson Hole, it's kind of shadowed in white because those are mountains, so less sagebrush. And so we will just go a little more into like how it is that this place is part of that defend and grow the core. So land use history in Grand Teton, and Anne had talked about the visitors and the importance of this place to many people. And it's really important to also recognize that humans have been connecting with this landscape for thousands of years. So this is nothing new. It's been very important. There's been a lot of connection and continued connection with the land by many affiliated Native American tribes. around the turn of the century, late 1800s and most early 1900s, we had European settlement after the Homesteading Act in Jackson Hole. And well, so one of the change agents with sagebrush ecosystems is that land use conversion. So here in Jackson Hole, there is the sagebrush steppe was converted to cropland and to hayfields for ranching. So it was native vegetation was removed, irrigation ditching put in for flood irrigation, as you see, and seeded with non-native species, and namely smooth brome or Bromus inermis. Here's another look at what became known as the Kelly hayfields. This is near Kelly, and this photo is taken from Blacktail Butte, if you're familiar with that, that feature. And another angle on it, again, there's Blacktail Butte in the foreground and the Kelly hayfields in the background that is being cultivated. And that represents thousands of acres. And this area is important for wildlife. It's at the heart of summer, winter, and transitional habitat. And it's the migration corridor for moose, mule deer, pronghorn, and elk. You can see that in the yellow, those are converted hayfields. And there's also a unit that's on the bottom there of the slide that's south of the airport, the McBride unit. And that's a project. We're also working on restoration for greater sage grouse that's associated with Jackson Hole Airport. So again, just to orient you, that kind of diamond shaped feature in the middle is Blacktail Butte, and to the left of that is the Highway 89, for those locals. And then just to the south, this is where the park is continuous with the National Elk Refuge. So a really important area for wildlife. I'm tying this into the sagebrush conservation design. The dark blue is the core sagebrush area, so it's super healthy, intact ecosystem. A lot of what you see out in Grand Teton is you'll go out and see 0 non-native plants, which is just unusual to say of any system anywhere you would plant your feet on planet Earth. In red outline is the hayfields, the Kelly hayfields restoration area, and you can see that's in the growth opportunity area. And again, this is kind of continuous with the National Elk Refuge. So a really important area for us, really strategic. Then a bit about our restoration techniques. Again, going to this map and zooming in on some of the aim with the restoration area. What's in green has had restoration initiated at some level. So it's been 15 years, with the first site being in Aspen Ridge, which is in the upper right, in 2009. And we've covered 1,425 acres thus far here, plus some acreage at that McBride site. And that represents, about a third of this goal of restoring 4,500 acres. That light blue strip represents the area we're working in right now. So we're in the process, but has not yet been seeded. And so this is what it looks like a little bit. We have the hayfield that is dominated by smooth brome. It's a non-native, long-lived perennial soft-forming grass. And it's a monoculture that excludes native plant species. And it's a limited forage and habitat value. And again, in the spirit of crediting slides, this is Eric's slide, as are many of these. We remove invasive plants before we remove smooth bromes. Other invasives like thistles, this is musk thistle, hound's tongue. And then we go into the pasture grass removal, which is focuses on using those large-scale agricultural type methods from tractor and boom spray, using herbicide to kill the smooth brome, sometimes UTVs to remove, to navigate in areas where the terrain is rougher. So this is the Slough South unit, the most recent one that we've been working in, and it kind of runs right up to Blacktail Butte. So there's a little bit of that hillside you see. And After a couple of years of treatment to remove the smooth brome, we drill seed, and this drill seed is a way of getting the seed into the soil, and this has a couple depths. So there's a couple levels, a couple different seed mixes you can use, and one would be more superficial, and then one would vary the seeds a little bit, so it kind of can align with what the seed needs are for these diversity of species you get out there. And after seeding, work isn't quite done. There's still follow-up treatments on to look for those invasive species like the thistles and houndstooth that could cause great problems to this site that's been opened up. And now there's light, there's space, so they can take that opportunity. And here is our ACE crew, American Conservation Experience Youth Corps, that is working on treating a restoration site. Excuse me, this is a crew from this year, and it's like doing great. We've had such great success having them out there and roving, and there's actually a double crew of 16 people. So it's pretty amazing. And Molly Murphy's been directing their work and the invasive plant needs. And so soon after that, next year, you're going to see the seedlings emerging, these little seedlings of grasses and forbs and shrubs. But I still need to back up to talk more about those seeds, because it's such a major process to get the native plant materials that you need for restoration. You can't just walk into Ace hardware store and bulk order some seed. So we have a program of collecting seed within the park and then cleaning that, sometimes offsite, sometimes in the park, and then ultimately storing it. And we purchased a seed cooler a couple of years ago to protect that major investment by keeping the seeds at the proper temperature and humidity. And there's a lot of thought that goes into what those species are. So it could be, of course, what are the species we want on the landscape that reflect what's in the native system that's important, like the antelope bitterbrush. And here staff are collecting that seed using a racket to hit the seeds so they fall into this bucket. And that's a really important plant, as we discussed, for the moose in the winter. So we want to get that species. And then in other cases, we're really looking towards those workhorse species. Like, what are the plants that you can gather a volume of, and you can maybe grow them out in a seed increase field? We have a couple here in Colorado and Idaho that send the seed off, and it gets grown in a more like farm agricultural style, so you can harvest those seeds at greater volume for 2 to 4 years. And this is all aligning with the native seed strategy. Here's a map of seed zones. So this is mountain big sagebrush. And so seed zones are specific to a species, and it means that there are different ecotypes, and that's different genetics. So that we've got the species in the park, in the Greater Yellowstone ecosystem, which is Northwest Wyoming. And there are other mountain big sagebrush throughout the West, but they could be very different, very different genetics. So something that you get from California might not do so well in here in Grand Teton. So it's a part of the practice to get seed within your seed zone. But if we zoom in a little bit, the color scheme's changed here, but you see the Greater Yellowstone ecosystem is outlined in black, and the park, Grand Teton, Yellowstone, number 1 and 2, Glacier is number 3 up there. The seed zone around Grand Teton is this green, this teal color, and you can see that's not just in Grand Teton, but it's in the surrounding Forest Service areas around us, in Yellowstone, and even in Glacier National Park. So that means that there's this opportunity to collaborate, to join forces and find ways to better collect the seed and grow it out and save money that way. So there are collaborations right now in the park with some help from bipartisan infrastructure law funds. And I'm really grateful to Katie Vincent, who's been coordinating a lot of this in many of our parks. And one other thing we do is sometimes we can salvage plants or get the seed and grow it out. We have a small operation in the park, in our nursery. And if we want more than that, we can go to some contractors and get a little bit more volume grown out. It still is a small scale as far as implementing that as a practice with our restoration because of the time and effort that goes into doing that versus compared to seeding, direct seeding. But we are doing that on a small scale, and we do have some 7,000 plants that were put in last fall, and we're going to be monitoring those. We've seen a lot of them have survived the first year. And some results from what this looks like. The first year, it might look a little ugly. It's this is a lot of pennycress. I've also seen a lot of prickly lettuce coming in. So it's like these non-native annuals. Sometimes there's like also some native annuals too, but it can be just like kind of overwhelming. But you look through and you'll see the seedlings coming in. The 2 years is a different site, Reniker. You can see the rows that were planted with the seed drills. So those two example of the two different seed drill rows. There's the little sagebrush coming in and some native grasses that come in under that. So after some time, those invasive non-native annuals will be outcompeted. This is another site at 6 years, Henry, with a lot of native grasses and some sagebrush as well. Another site on the west at 9 years, with a lot of grasses, some forbs, not a lot of shrubs. And the aspen unit at 14 years, which we've seen has had the most diversity of all forbs, shrubs, and grasses. So it's pretty nice shrub establishment there. This is a picture from last year. It looks similar this year. And then all this is also expressed and communicated much better with monitoring and research. And we've been monitoring, and this has been really important collaboration with the Greater Yellowstone Inventory Network, the Inventory and Monitoring Network, the Greater Yellowstone, in particular, Kristen Legg. And this protocol has been implemented in the intact sagebrush systems for over a decade, since 2012. And just recently, in the past 3 years, we decided to shift our restoration monitoring to mirror that protocol, so we could get a great reference site, right? So there's been a lot of work working through sagebrush and how to be monitoring our restoration, working with that INM network. And so in fact, Sienna Wessel, she came in and did the work. She took the 11 years of data and evaluated how was our restoration doing across all sites. And at the time, there were 13 restored sites to look at and 9 intact sites that she compared to. And all in all, what the data were showing, and this is sometimes you could see this on the ground anecdotally, sort of corroborated with some things we had seen, like one site, Elba West, being high in native grasses, but not so much in the shrubs, and aspen being having a good sagebrush establishment, and other shrubs too. Also looking at the plant diversity, the 2 lines show a couple different types of sagebrush, but both of those represent reference sites. The intact sagebrush is dryland, shrubland, and a mixed shrubland type. And the diversity of those restoration sites varied, but where it was below the diversity, the species richness that we saw at the intact sites. The graminoids or grasses bumped up, they filled in a cover increase over the first couple of years, and they were markedly higher than the intact. So those intact are those horizontal lines across the picture, across the graph, and like 20 to 30%. And then the grass proportion in our restored sites tend to be higher. So good news is there were a lot of native grasses but a lot of them. Invadedness was higher, but I'll also note this would be non-native plants. So, or species like cheatgrass and thistle are their high priority species, is really low. So that's not what this represents, but it's just this, this measure of the other species that were not in the intact site. And then all in all, like those drivers of restoration is what we wanted to know. Is like, well, so here are the outcomes, what's behind that? And some things you have less control over, like, well, the age, as the age progresses, it changes things. That's understandable. And then interannual climate variability. So that's meaning what happens in that year that you seed. So you seed in the fall. And so what happens over that winter with snowpack and the spring temperature and precipitation is, and the moisture available is going to influence the outcomes. So it's something we can't manipulate. We could if we wanted to install irrigation, right? But then the seed mix design, that's something we do have control over, and the soil properties, which we don't. But what this led us to do, our next phase is here's the results. What do we change about our practice? And what do we want to measure scientifically? So, working with Daniel, our staff, met with him and Trevor Bloom with the Nature Conservancy at the Times, now forest botanist. And we just talked about what do we want to know the most about? And we were able to kind of come to like, let's test 2 different seed mix types of how much forb to shrub to grass ratio we had, and soil tilling versus no tilling. So that is what we went forward with and implemented as some treatment shifts, but we did that in a way that we could test that more rigorously. And that is the subject of Anne's work. You can talk about that study.
Perfect, thank you. So as Laura said, my work was kind of birthed from the results of Sienna's work previously. And so if you look at this map again, just to kind of orient ourselves, the green polygons are areas that were previously restored, and then the tan polygons are areas that still need to be restored. So if you look at that little star kind of directly to the east of Blacktail Butte, that's where our experimental sites are. And that's where the entirety of my work takes place. So this is kind of another map, if this helps you more. This is Sienna's map and all the sites that she surveyed. And again, that little star is where I'm collecting my data. And then if we zoom into that, we have our site and we have our experimental plots. And so as you can see, both Daniel Lachlan, along with the wonderful people at Grand Teton National Park, kind of created this experimental design before I came on. So big thank you to them. And as you can see, they designed it in a way that there are 10 experimental blocks. And within each block, there are 4 different experimental treatments. We're looking at both seed mix and tilling. So we have 2 different seed mixes. The seed mixes vary in the proportion of grass seed and the proportion of forb seed. And then the tilling, we have a no-till treatment and a tilling treatment. So again, these plots, each square is 30 by 30 meters large to kind of give you a reference. And this kind of summarizes what I said. Again, we have about 40 30 by 30 meter plots. We're looking at 4 different combined treatments. And our overall goal is to determine what management practices most successfully transition to smooth brome monoculture back to intact sagebrush steppe. And we're going to be monitoring that by looking at both species composition and species diversity, as well as shrub establishment. So to start off with, again, the wonderful people at the park did the tilling. And again, this was before I came on, but thanks to the Grand Teton National Park Foundation, the park was able to purchase the disc harrow, and that's the machine that they used to complete the tilling. So again, it's on kind of like the agricultural scale. So they're using a tractor here. This is just interesting. This is the Google Earth photo of our site. And it's interesting because Google Earth captured our site in the middle of tilling, which is really cool. So you can actually see they were starting the tilling process just on the east side. And so you can still see the dark kind of blackish squares. Those are the plots that they had tilled. So this was before seeding. And so you can see there's a little square and that's the tilled plot. And then the square underneath that looks just normal, like tan, that's the no-till plot, and then below that again is the till plot. So it's just kind of fun and interesting to see from the aerial view. And then if you zoom in even further on Google Earth, you can actually see the tractor working, which is pretty cool. And you can see the lines that it was kind of driving. You can see where it turned around. And this is just kind of fun and neat to see how the tilling process was done. To kind of get more into the seed mixes, the two different seed mixes that we are utilizing in this experiment, we call them seed mix A and seed mix B. And it's important to note that both seed mixes were seeded at the same rate, so we didn't change that between the two treatments. Also, the percent of shrubs is exactly the same, so we're not changing the shrub percent. Both species mixes or both seed mixes, excuse me, also have the same number of species and the same type of species. So the only thing that we are changing is the percent of certain species within the seed mixes. So here you can just see these two different pie charts, and it breaks down the percentage of grasses and forbs and shrubs. So seed mix A has more forbs than grasses, and seed mix B has more grasses than forbs. Kind of looking a little bit more into our experimental design. Again, you saw previously this map on the left. And then if you zoom into one of those squares, I've blown that up on the right. So to kind of orient ourselves, the right is one plot. And this is a 30 by 30 meter plot. So that means that each one of those tiny little squares there is one square meter. And so that big red area along the kind of outside, that represents our buffer zone. So we're not collecting any data there. That's to take into account edge effects. So if something maybe creeped in from the edges, or GPS inaccuracies. So typically with a GPS, you have maybe 3 feet to 3 meters of kind of variation. And so that also takes into account that. The yellow squares are where we're taking data. So essentially, to take data, we have this big PVC meter by meter kind of thing, quadrat that we make. And then we lay it down exactly where it belongs on the grid, again, those yellow areas. And then we look down at the quad and we take percent cover. So that means we identify each species and then we write down the exact percent that we're seeing. We're also taking data on the substrate. So how much dirt is there? How much biocrust is there? How much rocks are there? And then we're also taking shrub establishment data. And so that means that when we find a shrub of interest, so big sagebrush or an antelope bitterbrush, we are also counting those and we're measuring their heights and crown widths to kind of get an idea of their establishment. The little blue dots there, that's where we're taking soil. We're taking soil cores. And that's to kind of determine if there is variation in soil texture and other soil properties across this site. And if so, how is that impacting, again, the diversity and shrub establishment? So we kind of have two questions that we're asking here. The first question is related to native diversity and composition, and that's what we're doing with those percent covers. And if we're kind of looking at the literature and previous research that people have done, there's a lot of conflicting tillage literature. Some studies say tilling increases invasive presence. Other studies say that tilling and soil disturbance increases diversity. And so it's a big question. It has a lot to do with what's in the seed bank, what seeds are present. It has to do with the site history. It has to do with specific site characteristics. So this is a big question. It'll be really interesting to see if tilling has an impact on our sites. I have a feeling that it will. When smooth brome kind of establishes this really thick mat. And that means that you have really thick roots. So if you don't kind of break up those roots, sometimes the native seeds that you seed can have difficulties kind of establishing and growing. So theoretically, tilling could help in this instance, but again, it's kind of a big question mark. Also in restoration, a lot of times, as Laura was talking about, sometimes you get restoration that has a lot of native grasses, but maybe more native grasses than we want, or than compared to intact historic sagebrush. There's a multitude of reasons because of this. One, grass seed is way easier to get. So forbs, if you think of like a wildflower, how many wildflowers you'd have to find to get enough to seed that one specific plant. Grass is more expansive, it's easier to pull off. So grass seed is more easily available and it's less expensive. Also, it was kind of historically in the past recommended to seed grass because it helped outcompete non-natives. However, that also means that heavy grasses can outcompete native forbs and native wildflowers. So it's kind of a fine line we're walking with the ratio of seed mixes here. So that's important to kind of think about as we're looking at our different seed mixes. And then also our site exists along a soil gradient, a soil texture gradient. So essentially out to the east, we have some mountains, and then we're kind of in a valley, the valley that we're restoring. And so your coarser, more sandy, bigger particles of soil are going to exist kind of closer to the mountain, and then the finer soils are going to kind of migrate further into the valley. So we also have a soil texture gradient, and this can also influence what types of plants establish where. So this is also important to kind of think about when we're restoring different sites. Our second question relates to shrub establishment and reproduction. And I'm just going to say here that sagebrush establishment and sagebrush restoration in general is highly variable across the West. So let's say you know something about sagebrush restoration in Utah or in Idaho. It's going to be completely different here. So it's really hard because you have to kind of take everything with a grain of salt. I worked with some people in Utah and they couldn't get sagebrush to establish or grow at all. And they had to grow everything out, all of the sagebrush out in greenhouses and then individually plant them at their restoration sites. But we don't have to do that here. Sagebrush establishes pretty well here. So again, that's what makes this so challenging. But again, question 2, shrub establishment and reproduction. We're specifically looking at big sagebrush, which has poor establishment rates across the West, but again, we're lucky here that our establishment rates are pretty okay. But it's important to note that we have variable success in sagebrush establishment kind of across our sites, and so we're kind of trying to understand why that is. And then we're also looking at antelope bitterbrush. That's that shrub that we showed that those moose were grazing on and foraging in the winter. Antelope bitterbrush is also very important winter forage for a variety of ungulates. It also provides seeds for rodents, and it's also very tricky and variable across the West in terms of establishment, but it's a very important shrub as well. And overall, bitterbrush establishment is in decline across the American West, which there are some theories why, but no one really knows. And so these are the 2 shrubs that we're kind of really focusing on in our experimental plots. And then this is a soil map of the whole Antelope Flats Valley, where all of this restoration is occurring. So again, to kind of orient ourselves, that diamond triangle shaped feature on the left is Blacktail Butte. And then if you can see our plot that I'm looking in is Sluice South. It's right to the east of that. It's the one that kind of has some blue and yellow in it. So that's kind of where I'm working. And so this is a map of soil type. And so this is showing that there are a lot of different types of soil in this valley. And a lot of times people overlook soil, which is unfortunate because it's such a vital and important part to restoration and plant growth. So this is important to take into account. It's why we're taking soil cores at all of our sites, because it can impact lots of different things like, water storage, again, what species are more likely to establish. So this is also a really important part of the story and can help inform management in the future if we can start understanding these interactions more. So this is a fun little slide. We actually got to start our data collection today. So last minute, I threw these photos in of my wonderful techs. They're sitting right up here, Dylan and Skylar. And so this is us. We established our very first plot number 1, and we started taking some data. I believe this was in a tilled grass plot. And as you can see, we have our measuring tapes lined up and our quadrats there, and we're, again, my techs are doing a wonderful, painstaking job of IDing each one of those grasses to species, which is really hard, but we're getting there. And then these are some of the really cool forbs that we just saw within the plots. It was really exciting. We even saw pollination actively occurring on some elk thistle. We saw a lot of different species of forbs, native grasses, some non-natives, but that's to be expected. It was overall really exciting. We even saw a pronghorn foraging in it. We didn't get a photo, but that was also really exciting. So it's proof that these ecosystems are important, and they do provide important forage for wildlife as well as plants for pollinators. So what's happening next? One of my technicians, Dylan Romero, again in the audience, he is an upcoming master's student, and he's going to be looking specifically at these soil types. And so he's going to be going to all of these old, previously restored areas and taking soil and analyzing the soil to try to understand how microbial and chemical soil indicators differ between these different sites, and how does that maybe impact the results of restoration. He's then going to look at how can soil inoculum, which is specifically the microbes and mycorrhizae within soil, help improve sagebrush growth. So essentially, they're going to add different soil to sagebrush growing in a greenhouse and see how those different microbes and mycorrhizae can improve the growth. Over to you, Laura.
Okay, real quick, just a couple other things we're doing.
I'm not following something. I don't know what a forbs is.
Yeah, forbs are not grasses. Forbs are not grasses, and they're not shrubs. So a forb is like a wildflower. So it's not woody. It's a plant that's herbaceous. So just think like a flower.
Anything else? So we have sagebrush, we have grasses, and then we have everything else.
Yeah, so typically it's divided into shrubs, which include all types of shrubs. So that would be sagebrush, bitterbrush, a lot of other ones, Ericameria. I can only think of Latin right now. But yeah, thank you. Rabbit brush. And so we have shrubs, and then we have forbs, which are a lot of our wildflowers. And then we have grasses. So those are the 3 kind of that we're dealing with, and then trees is also another category.
So the forbs you also collect and put in. So are the forbs also native?
Yeah, so they collect native forbs and seed them within the mixes. We are also seeing all of those photos that I showed were native forbs that we saw growing. We are seeing a lot of native forbs. There are some non-native forbs or wildflowers like dandelion and some other ones that we're also seeing. But yeah,
you're seeding.
We're not seeding them. We're seeing them.
Oh, you're seeding.
Yeah. Good question.
Yeah, and I'll just wrap up with the couple of things going on now and future, and then we'll have time for questions. We have a scientist in park intern working at a year-long remote position, and Allison Pagaliliwan, who's looking at that intact sagebrush and the restoration to set up some summaries and characterize the sites, and also write our code so that we can do that in the future more seamlessly. And there's a USGS-NPS at Fish and Wildlife Service collaborations, that's Grand Teton and National Elk Refuge, and with our fire staff to be looking at the fire and invasives risk modeling, and that's something that Matt Germino has done at some other parks and is going to apply that here. So that'll be really helpful for this project and for defending the core as well. And we will be seeding that site and some of that McBride site in this fall, and starting some additional restoration next year. And so that's like a big thank you to a whole lot of people. And we are open for questions.